Paper chromatography is a separation technique used to separate a mixture of dyes. You can use it to identify the dyes present in an unknown mixture, for example, those in food colorings.
You might be given 4 known food colorings labelled A to D, which each contain just one dye. You may also be given a sample of food colouring that is a mixture of different dyes, labelled U. Your first task is to place small amounts of each of the food colourings on a piece of chromatography paper. Cut the paper so its width is narrower than the beaker you will place it in. This means that the paper won't touch the sides of the beaker.
Use a pencil to draw a horizontal line 2 centimeters from a short edge of the chromatography paper. Mark 5 pencil spots at equal intervals across the line. Keep them at least 1 centimeter away from the ends. You use a pencil, not a pen. The ink from a pen would travel up the paper and interfere with the results.
You then need to put a small spot of each of the known colourings on 4 of the pencil spots. You can use a very thin glass tube called a capillary tube to do this. Simply dip the capillary tube into the food colouring and then touch the end onto the paper. Try to make sure each spot is no more than 5 millimeters in diameter. Let each spot dry for a few seconds and repeat so you have enough food colouring on the spot. Then put a small spot of the unknown mixture onto the final pencil spot. Make sure you use a different tube for each food colouring to prevent cross-contamination.
Remember to label each spot in pencil so you know which is which. Now you are ready to carry out the chromatography. Food colouring is soluble in water, so you will use water as the solvent. The water will travel up the paper, dissolving the food colourings. They will then move up the paper with the water. The different dyes will move different distances, spreading them out.
Pour water into a small beaker to a depth of no more than 1 centimetre. Tape the edge of the chromatography paper, that is the end furthest from the spots, to a glass rod or pencil. Rest the rod on the top edge of the beaker. The bottom edge of the paper should dip into the water. You must ensure that the pencil line is above the water surface and that the sides of the paper do not touch the beaker wall. You will see the water travel up the paper. Make sure you do not touch the beaker during this time.
When the water has travelled at least 3/4 of the way up the paper, carefully remove the paper. Draw another pencil line on the dry part of the paper as close to the wet edge as possible. Now leave the paper to completely dry. This is best done by hanging the paper up inside another dry beaker. You might have to leave it overnight.
You can now analyse your results and calculate the RF value of each dye in the food colourings. You'll need to use the equation RF equals distance moved by the substance divided by the distance moved by the solvent. The distance moved by the solvent is the distance between the 2 pencil lines. The distance moved by the substance is the distance between the bottom pencil line and the centre of the coloured spot. Start by calculating RF values for the dyes in each of the known food colourings A to D. You might find it helpful to put the measurements into a table.
The table here shows the results for all the known food colourings. For A, the distance travelled by the solvent is 58 millimeters, and the distance travelled by the spot is 45 millimeters. This gives an RF value of 0.78. All the other results and RF values are in the table.
Then repeat the RF calculation for the unknown food colouring, U. Use the results to work out which food dyes were mixed to form the unknown food colouring.
The unknown food colouring U contains 2 dyes. One has an RF value of 0.78 and the other has an RF value of 0.24. We can conclude that the unknown food colouring is a mixture of the dye found in food colouring A and another dye.